and welcome to my tutorial channel. This is the first lecture of University Physics 1, which is about mechanics. Before we start discussion on mechanics, we need to get familiar with the concept of measurement, units, and dimensional analysis. In the first lecture, I briefly discussed the base units and in the next session I will introduce the international standard of units. Science and engineering are based on measurements and comparisons. So we need rules about how things are measured and compared. Also, we need experiments to establish the units for those measurements and comparisons. One purpose of physics is to design and conduct those experiments. For example, physicists have developed clocks of extreme accuracy so that one can determine and compare any time or time interval. Do we need such high accuracy? Here is one example. Without clocks of extreme accuracy, the global positioning system or GPS does not work well. We discover physics by learning how to measure the quantities involved in physics. Among these quantities are length, mass, temperature, pressure, and electric current. We assume that each physical quantity in its own units by comparison with a standard unit. The unit is a unique name we assign to the measures of that quantity. For example, we use meter, which is shown by letter M, for the quantity length. The standard corresponds to exactly 1 unit of the quantity. We can define a unit and its standard in a way we care to, but the important thing is to do so in such a way that scientists around the world will agree that our measurements and definitions are both sensible and practical. Once we have set up a standard, for example, for the length, we must work out procedure by which any length can be expressed in terms of the standard. For example, we can express the radius of an atom or the distance between the Earth and the Sun in terms of the standard of length. Here is the example. So, for example, the meter is one example which we can use for the measuring the distance between the Sun and Earth. Sometimes we can use a tool like a ruler to directly measure the length, but in some cases we have to measure things indirectly. For example, we cannot use a ruler to measure the distance between New York and Chicago. Now there is a problem. We have too many physical quantities. So in that case, should we define a standard for each one? Fortunately, most of physical quantities are not independent. For example, speed is the ratio of uh, length over time. So it depends on length and time simultaneously. Therefore, we don't need to define a special unit for speed because we already have defined units for length and time. So what we do is to pick out by international agreement a small number of physical quantities such as length and time and assign standards to them alone. We call them base quantities. The base quantities are those that we can express other physical quantities versus these quantities. Uh, the base quantities we use in University Physics 1 are as follows. Here is a table. The first column is the quantity. The second column is the unit name. And third one is the unit symbol. The first one is length, whose unit is meter, and the symbol for that is m. The next one is time, whose unit is second, and the symbol for that is s. And finally, we have mass, whose unit name is kilogram, and the symbol for that is kg. Base standards must be accessible and invariable. For example, the distance between one's nose and the index finger is accessible, but it varies from person to person. So this is not a good measure for a standard. In the next lecture, we'll talk more about the base standards and also the international standards of units.